Hello friends, welcome back. In this session, we will understand SYCL classes. In the previous session, I explained you the differences between the DPC++ and SYCL. I walked you through a very simple hello world code and I explained you the pros and much more details about SYCL in the previous session. In this session, we are going to go a bit closer to the programming part of it, and the first thing that we need to know is the basic SYCL classes. We are going to use the SYCL classes frequently and we will learn that here. The first one is a device class. This is a very simple class which helps you in querying information about the device to which you want to offload the work to. Please understand, you can use CPU, GPU or FPGA, and this class will help you in obtaining more information about that particular device. You could see the code here. It's very simple and easy to understand. First, queue is created and then you use the queue.getDevice method and you will get a lot of information about the device, which include the name, the vendor, the version, the memory details and lot more. Even the clock frequency, cache related information, all these will be made available to you. And this is going to get you more information about your device. Well, what next? The next one is device selector. The name says it all. Yes, this is a selector. It enables you with the runtime selection of the devices. It can be CPU, GPU or FPGA. The default selector will also go ahead and select the best of the available option. Now, please understand, you can run your code in CPU, GPU or FPGA. And in case you want to go ahead with the GPU, you will create a GPU selector, pass it as an argument for the queue, and that's it. It's very simple. You can see the code here. We have got default selector option, host selector option, CPU selector, GPU selector. So the world of usage is going to be very simple and it provides you a lot of options. So what next? The next one is queue. This is one of the most important classes to be understood, and it is employed to submit command groups where a work is submitted and to be executed on the device. What do you mean by that? Very simple. The work is submitted to the device only through the queue. Whatever you want to do, it can be done only through the queue. Remember that, and that's what I have been telling you. Now, one queue maps to one device and multiple queues to one device mapping is also possible. Command groups are submitted using queue.submit option. You can see that here we have got queue.submit option available and it's going to help you. This is very important, and every code, whatever we are going to see, will have queue. So anything and everything that you do with SYCL or DPC++, you will have this queue playing a major role. So remember it. Well, choosing where a device has to run, choosing where the device kernel has to run, to be very precise. I have just conveyed you, right? Each queue is associated with a specific device and it can be a GPU, CPU or FPGA. You've got GPU selector option, you've got CPU selector option, all these are highlighted here. So it is you are the person who is going to select where your device, where your code has to run and which device your code has to run. And you can also go with vendor specific selection as well, and we will see that in near future. The custom selector, the custom device selector options are also there, where you can say that I want this vendor's device and only when this device is available, this code can be run there. Those kind of options are also available for you. You can prioritize. You can even give ranking. So that's very important for you to understand. Well, the next one is kernel class. What is it? The kernel class eventually dispatches methods and data for executing code on the device. Remember it. The kernel invocations are executed in parallel by calling the parallel function. This is very important point to understand. I have got parallel underscore for here. Earlier in normal C programming or C++, we will have only for. We have got parallel for here. So the kernel invocations are executed in parallel by calling the parallel function, and the kernels are executed for each element of the range. So we will talk about this range, ID, all these things shortly. But for now, you understand that things happen in parallel, making life easier and much faster for you. So this is what I told you. For normal for loop, we have been using this for a long time. For I equal to 0, I less than something, I plus plus, inside you have the value operation to be done. But when you come with parallel for, we have got parallel underscore for here, and this makes faster parallel execution. So this is the beauty of it, right? When you start coding it, you will start realizing it. So for to parallel for transition has happened seamlessly here, and this is the beauty. We will learn more, and the next thing is going to be on the memory models, where we will learn a lot more content, and it's going to be with practical stuff as well. Thank you very much for following my channel and content. If you have any questions, type it in the chat section. I'll be very happy to answer them. Thank you.